there are several communities within the domain of artificial intelligence, AI, and each of them have their own perspective and schools of thought. And the most interesting part is that since brain is a complex biological organ of the body, that even after so many centuries of efforts to understand what it is, we are still not clear what is it that is intelligence and what should we call artificial intelligence. And there are two schools of thought. One which says, which defines, differentiates AI into two groups: weak AI and strong AI. Weak AI versus strong AI. Both are in the realm of AI, but being differentiated into two parts. So we'll try to clarify these two and then see if we can compare and contrast quickly without getting too much of technical details. Weak AI, also called narrow AI, is basically that part of that application of AI that works in a narrow domain. Narrow domain. Okay. Now, narrow domain means that it is only limited to one specific area. That's one way of saying that. So weak AI is something that looks at a small subset and works in that area. One of which is called data science. Data science is an interdisciplinary field where multiple schools of thought and sciences are coming together to come up with analysis on unstructured data using systems, using algorithms, using processes, a scientific method to get there. Okay, and then come up with results and discussions, come up with insights into several dimensions that we might not even know about. And data science, of course, is also related to data science and big data. By the way, I'm trying not to use terms that we have not discussed so far, but unfortunately, I can't help it. We will go along and understand these as we go along. But you might have come across these terms for big data, data mining, and so forth. So that is basically weak AI. Whether AI is impossible to achieve or not depends how you define it. We have defined AI, or AI can be viewed as a quest to design such a program that behaves rationally, it's very intelligent, and a rational agent, so to speak. And once again, we'll come across that. So depending upon how we define intelligence, we can then agree or disagree whether it's possible or impossible. When about half a century ago, when work started in the computing area in AI, okay, the assumption was that weak AI is possible. And that was the assumption. And then as we move along, we will see that people begin to argue and differentiate and disagree with each other. Somebody saying weak AI is not even possible. Somebody saying strong AI. And then they're trying to compare and contrast each other. So the point is, for instance, can machines think? Can machines act intelligently? And various people have various views in that. Now, somebody says that to ask a question whether a machine can think or not is perhaps as relevant as asking whether submarines they swim or not. Right? Now, the thing is, what are we saying here? We are saying here is a definition that we are aware of. And so let's say a definition given in the dictionary defines swimming as something which is done with limbs and you move forward. You move your limbs and you move forward in the water. A submarine actually doesn't have limbs. However, it still moves forward. It swims within quotes. So now we're talking about two different things. If you remember previously, we also discussed the concept of flying machines, aeroplanes. Aeroplanes, as we all know and agree, that they fly. But if you look at the definition in the dictionary of flying, it says it must have wings to fly. So these two are very disparate views of the same thing. Likewise, when it comes to intelligence, some people like to think that things can only be intelligent if they exactly behave like the human brain does internally. And others that say that yes, that's one way, but why don't we create programs that can emulate, mimic, or simulate the working of the brain and create and call that as intelligence? So, I tell you, as we started very, very early on, we said this previously, there aren't two clear set of thoughts on this. And of course, this is acceptable in sciences, in areas which are still under evolution, and AI is basically one of them. Part of weak AI examples are typical. You've come across virtual assistants, and a list is given here. You can take a look at that. Each one of these internet chatbots, okay, and so forth, they're all examples, I'd like to call them as weak AI examples. They're limited in their application area. Moving to strong AI. Strong AI is defined as a machine that can apply intelligence to any problem in general. So it's not limited to applying intelligence to one small subset or a small set of a defined area. Okay, and in that context, if you remember, I mentioned the word general problem solver. So the concept there is that strong AI, a machine can be called strong, depicting strong AI characteristics, is one that has generic intelligence that can be applied to various focus areas as opposed to limited to one. Also, intelligent machines or machines who have this kind of ability will have perhaps a few more added features in them. They can think, they can feel, they can perceive. Now, most examples of, let's say, these virtual assistants and other things we discussed previously, they do not have that particular aspect in them. Maybe they build it up subsequently, but until that happens, we would keep them away in terms of thought processes, strong versus weak. Alan Turing, we talked about the Turing test. Alan Turing also tried to differentiate between machines that think like humans and machines that act like humans. And if we consider a very typical example of something called a Chinese room, it's like a program that takes inputs in Chinese characters. The input to this machine, called a Chinese room example, the input to this program, let's call it, are Chinese characters. And the program, what it does is, based on its understanding, intelligence, whatever that has been built in there, it creates new Chinese characters as output. So if this machine, in fact, this machine has gone through or passed rather the Turing test, because according to the test, you keep asking questions, writing things in Chinese, and this program churning out characters in Chinese, and as per Turing, it has passed the Turing test. Now the big question is, does this machine depict strong AI or weak AI? And once again, on the face of it, we don't know how this was developed, but if this were developed on the basis of the human mind, the way, the replication of the mind itself, call it strong or weak AI, and then making it generic enough. That's the fundamental thing. If this Chinese room can actually do the same thing with other languages, I would still call it weak AI conceptually. Now, however, if this intelligence, the same machine, can actually demonstrate intelligence in other areas, making decisions, making analysis, and so forth, okay, perhaps by this definition, I'd like to call it strong, depicting strong AI. And this once again, this definition has been going on, being debated, for ages now. The other thing that strong AI talks about is the machine that depicts intelligence, is that the machine itself should be aware of its surroundings as well. Like emotions and what is where the machine is, what's going on around it, as we do as human beings, and based on that, then take decisions. So perhaps very quickly, if I were to compare weak and strong AI, I would like to summarize by saying that weak AI is trying to focus on limited set of application areas, not generic intelligence, as opposed to strong, where we're trying to focus on generic intelligence, one thing. And then the other point was that, whether we are looking at or emulating the behavior of the machine in correspondence with the working of the inner mind, versus the behavior of your program looking at the brain, let's say, as a black box. And as I said, this is the debate that's been going on for ages now, and you don't need to get kind of bogged up into it. The idea was just to demonstrate, the issues and challenges. And once again, I come back to the same point. This is a relatively new science as compared to others, and there are lots of opportunities for new Newtons and new Einsteins and so forth.